1 second. Okay, we're live, Bryan.
All right. Happy Friday.
Happy Friday. Happy Good Friday. Have some fish. So you hate fish.
I don't like fish.
All right. So today we're going to talk about we're going to talk about home Wi-Fi and networking. Now, this is something people love to hear about. They love to talk about. Everyone has a home. And they all need good Wi-Fi and networking and the types of devices that they're going to be networking at home. I mean, most of our customers they're business customers, right? Like mostly, we'll have business customers for like schools, hotels, all types of businesses, and that's what we mostly sell to. But we get a lot of questions from individual home users too that want to have good Wi-Fi, especially during the pandemic, right?
Oh yeah, definitely. We get a lot of those questions because of Pro AV too.
Pro AV, yeah. I mean,
There's a lot of guys going into homes and installing a number of different things, but that now includes Wi-Fi.
Yeah, for sure. And these guys, maybe their specialty may not be Wi-Fi. They're more into the AV, like the Crestron and the lighting systems and the Sonos and all that stuff, right? But then they need Wi-Fi now to connect all that stuff.
Yeah, that's the backbone now, right?
Mm-hmm. Mm-hmm.
Yeah, they're really good at like low voltage, but now they're getting in more and more into like networking. There's a lot of guys that have been doing it for a while now, but there's definitely a ramp-up training period for that. There's still a lot of guys out there that are not too familiar, and they rely on the vendor to train them, which is fine. We do a lot of training. But yeah, that is the backbone of the network. That's the backbone of my network.
Yeah, for sure. So, all right, so let's talk about what constitutes like a good home Wi-Fi network. First of all, let's start at the router now. So you have an internet connection, maybe Comcast or Xfinity or who do you have over there? You have
Frontier,
Verizon, something like that. They're gonna sell you the internet connection. They're gonna give you a modem, and usually it's a router combined, right? Like one device. And some people. And that's going to have Wi-Fi built in too, right? So it's going to have a modem, a router, and Wi-Fi in that router. Now, if some people are a little more advanced, like myself, I own my own cable modem, my own router, and you do also. You have your own router too. We're using those Microtechs.
Yeah, I have my own router. I use the ISP's modem as well. I didn't go out and get
your own modem.
Another modem like you did. You got your own modem.
Yep.
I did not do that. And there's reasons why you did that. Speed, right? It was one of those things.
Yeah.
But before you touch on that, like the one thing you have to consider, I think ISPs are starting to do this more. The advancements of Wi-Fi and these modems were really slow.
Yeah.
Right?
Yeah.
It was 11N. Now they're doing 11AC. Some of them might even be doing 11AX right now, but I think mine's 11AC Wave 2. But you got your modem. You bought your modem for a particular reason, and speed was one of those things, right?
Yeah. So I upgraded to like a gigabit connection, and of course Comcast would have provided me with their gigabit modem, but then I have to pay a rental fee every month. So I just went out and bought the latest, gigabit DOCSIS 3 modem from CommScope, so the other Armor Ruckus, they make all the cable modems, and they inherited it from some other purchases, but I got that, and then so I have my own modem, and then I have a wired router, a Microtech, which I have plugged into that modem. And no Wi-Fi in there, right? So what about you? Like, do you have your Wi-Fi disabled in the modem?
Heck yeah.
Yeah. So that's the main thing that we tell people is, okay, you're coming to us, you want better Wi-Fi. First thing to do is disable the Wi-Fi in that modem that you're renting or from your internet provider.
Yeah.
And usually it's pretty easy. You can just Google how to get into it, and it'll be pretty evident how to turn off the Wi-Fi interface on it.
It's pretty easy to do. But yeah, I turned off both 2.4 and 5 gigahertz on my modem.
Yep. So then, basically every house, to get full coverage, you're going to probably need about 3, for a normal size house, you need about 3 access points, like the Wi-Fi 6 ECW 230, right? So, like, I have 3 of those, and that'll cover my house really well, giving good speed.
Yeah. I might be getting a visitor. I'm not sure.
Uh-oh.
Yeah.
Oh, I see somebody.
No.
All right.
Yeah, I'll talk to you later. This is the life of working from home.
Yeah. So basically you'll need probably 3 access points to cover. Now, yeah, you could go out and get one of these meshing systems, these Zero systems, or something else, and you'll plug it in, you'll be like, oh, I got great signal, and look how good the signal is, and yeah, it's working good, and then all of a sudden, like, it stops working one day for some reason, right? And you don't know why. There's no way to troubleshoot it, because, they're backhauling. Your neighbor could come in and have interference from them all of a sudden, and all of a sudden it doesn't work anymore, right? So
yeah, it's causing more noise, and then like meshing, you're really killing your bandwidth in between hops and things like that.
Yeah, especially for things like streaming video, 4K, things like that. You don't want meshing. Yeah, it works, but it's not going to work all the time. It's not going to work well, and especially if I'm an AV installer going in to set somebody's Wi-Fi up in their house, I would never install meshing, because they're paying you to come in. They can order that on Amazon themselves and have a halfway working system if they want. Like, if they're paying you to come in, you should be running Cat 6, Cat 5e throughout the house and hooking up those access points.
Yeah, so you might have touched on that when my daughter was coming downstairs, but yeah, so the modem in itself, like my modem, for example, will not cover my whole house. Right? So what happens is you don't have coverage throughout the house, so you need coverage throughout the house. So what do? You want to add a meshing system or more Wi-Fi, or like repeaters, for example.
Yeah.
Which is not the best way to deploy it at all, because you're going to start cutting into like the performance, and then you have all these IoT devices, so you're really cutting into performance when you're doing like meshing. Repeating, I would never do.
Mm-hmm.
That's even worse. But yeah, we get a lot of guys that want to mesh, but we're always saying wire everything, like you're saying Cat E or Cat 5e or greater. Is the best way to go. Yeah,
so in my case, we have these ECW 230s. They have multi-gigabit interfaces on them. They're Wi-Fi 6, 4x4, the latest, fastest thing. So, I wanted to use multi-gigabit switches, so I use the Ingenious 8-port multi-gig switches, and I have 3 of those within my house. So I have like one right in back of me here in my office. I have one down in the basement where the DMARC is and the cable modem comes in. And then I have one in the garage that kind of like bridges all the switches together. And these are PoE switches also, so I have like IP cameras on here, all kinds of stuff. I can actually show the Ingenious Mesh View, right? Let me try to put that up.
Oh, yeah, you are. We're doing.
If I had this, let me take a look at the topo view.
Yep.
Let's see. Yeah, this way we can kind of talk about it, right? All right, let me put this up here.
Yeah, I'm actually. We're talking about not meshing, and I'm also meshing.
Yeah. So, and what happens, Brian, when you do that? Like.
Well, you know what? On the meshing unit, I have 2 SSIDs. It's backhauling on 2.4.
Yeah.
It's not backhauling on 5 gigahertz. I don't want it to backhaul on 5 gigahertz. So
right.
I don't want the 2 access points to communicate across 5 gigahertz. I want them to communicate across 2.4. And the reason I did that is I have 2 access points in my house the second access point is in my garage, right? And the only thing I have connected to that access point is my door ring bell and my garage door openers.
Yeah, like the Internet
Uh,
Things devices.
yeah, exactly. So that's all. I don't have like really critical devices connected to that one.
Yep.
And actually, that's totally fine. But then I have my main access point, which is our 4x4 11AX. That's what I connect to every day. This is what we're doing this call on right now. But all my primary devices are connected to this one on 5 gigahertz.
Right. Right. Now I just threw up a picture of my topology, the topology view, and it shows everything right from the internet. Can you see that, Brian? You watching the stream?
Yeah. Yep.
Yeah. So I see, you can see the MicroTech router and then the multi-gig switches. And the nice thing about this Ingenious Cloud is it uses LLDP. It shows every device from every manufacturer. You can see I have like some SIP phones hooked up, some Ruckus APs, some Ingenious APs.
Sky Key connected.
Sky Key, all this stuff. So yeah, basically these switches are all linked at 10 gigabit over Cat5e cable. So I'm using those SFP plus modules, the copper modules, and these are all linked at 10 gigabit. They're short runs. They're less than 50 feet each, so there's no problem there, and they're super stable at 10 gig. And then the access points we have plugged in. Those are all linked at 2.5 gig too. Like if we hover over this link here, we should see speed 2.5 gig full. You're not going to see that live. I'm just showing the the screenshot here. But anyway, that's the topology of my network. So why is it important? So a lot of these devices, a lot of people are using these for AV type situations where they have a TV with like a Google Chromecast or Amazon Fire Stick in there, and they want to have rock solid like 4K performance, right?
Yep.
So doing meshing with any of that stuff, nah. I mean, it's not gonna really cut it, especially if it's far from a mesh point or it's hops away. You're gonna see buffering and all this stuff. If you have an access point, like I have one Wi-Fi 6 access point down near my TV, and that thing like streams rock solid at 4K, right? Never a hip cup. And then I have a projector down in my basement, and that thing I have like Google Chromecast and Fire TV, Xbox, all that stuff wired into that projector room switch there. So those devices are all wired in. That thing's even more solid, right? Like that's if you have the opportunity to wire these things in, definitely do it. You're going to get a much better connection than Wi-Fi always.
Yeah. Everything I'm running here. The only thing is the TV is connected directly, but everything else is pretty much wireless.
Yep.
Because of the world I live in, so I want everything to be wireless, so I can experience it for firsthand.
Yeah.
But yeah, pretty much everything is wireless. But there's definitely like hiccups that I experience that I have to readjust or whatever. But that's not a big deal for me. And I know it's not a big deal for you, but it's just the differences of like what you what you can do within your home. Like if you don't want to run cable or something like that.
Yeah. Well, no one wants to run cable, but in the end, it's the right thing to do.
But you have to, yeah.
You have to, yeah.
You have to for the best experience, right? Especially if you're in the Pro AV arena, you definitely want to run wire. More and more, we have a lot of customers that are deploying switches, multi-gig switches, and switches into homes.
Right.
24 port, 48 port. It's pretty impressive to see like these like major networks going into like these homes and things like that. So a lot of people are doing it.
There's so many devices now, like all these Internet Thing devices, like the Ring doorbells, the sensors. Like I have Samsung smart things with like all kinds of like leak sensors and things all over. I have hundreds of devices, right? So all that stuff uses the network. Somehow it gets back either the wired or the Wi-Fi network, right? Like so you hit on earlier. that we like to set up a separate SSID for Internet of Things devices, maybe even a separate VLAN if you're super security conscious, and maybe make that one 2.4 gigahertz because a lot of those devices still ride in 2.4. I know like some of the new Ring doorbells can do 5 gigahertz, but most of that stuff's still on 2.4. So you want to kind of separate that off so all that traffic's running around in one SSID, and then you can have your your computers and your TVs and things like that on a different SSID.
Yeah, and that's how I have it set up. I have just 2 SSIDs. You don't want to broadcast too many SSIDs, but that one SSID is all IoT devices, and that's only on 2.4.
Right.
I don't have the newer Ring, so it doesn't operate on 5 gigahertz. It only operates on 2.4, which is fine because I don't think you need that much speed anyway for the Ring doorbell. And a majority of the time, the Ring doorbell is just somewhat far away from your ISP modem.
Right.
So you're gonna communicate on 2.4 anyway. But it's okay. I mean, I can see really great video through my Ring doorbell on 2.4. But so I have my one SSID just operating on 2.4 and my primary SSID, which is operating on 5 gigahertz. I force all my laptops, tablets, whatever, on 5 gigahertz.
Right.
So they're getting the maximum speed possible. But if your house is really, really large, you may need more than one access point to get all these devices on 5 gigahertz because they're going to tend to want to move to 2.4 because they're too far away from like an access point, for example, right?
Right. So I mean, you could put one access point in a house and see that 2.4 gig signal everywhere probably, but it's not what you're going to want. I mean, it's like, that's going to give you like a bad experience. What you want is to have everyone on the 5 gigahertz, like you said, and have more access points in that house, maybe 3, 4 on an even bigger house, and then you want them to be on the closest access point on at the 5 gigahertz, not trying to connect to one at 2.4, like 2 floors down in the basement, going through all these walls and having all kinds of interference.
Right. Yeah, and that's what we run into. So with your ISP, I know I talk about this all the time because I run into this all the time, especially in residential. With your ISP's modem, their idea is you're going to have one wireless modem within your home, and it's going to cover your whole house. That's the idea, right?
Yeah.
And that should be plenty. So typically they have these modems set up with 80 megahertz wide channels, right? And so you only have one ISP modem or one wireless device that's serving the wireless clients, and it's operating on 5 gigahertz at 80 megahertz wide channels.
Yep.
As soon as you introduce other access points, you're starting to create more interference.
Yep.
And if you're still on 80 megahertz on all those devices, you have less channels to communicate across. So you're going to see more and more interference as you add. And the reason you're adding more access points is because you want more coverage.
Right.
So initially, when you have one ISP modem, you have these high speeds and things like that, but you don't have coverage throughout your house. So the idea is I want to have more coverage throughout my house. So depending on how many access points that you add, you might have to turn them down to 40 megahertz wide channels so you have less interference and you have connectivity throughout the whole house.
Right.
The overall average speed might slow down, but now you have coverage where you didn't have coverage before. So I couldn't connect in the corner of my house. Now I can connect.
Right.
And that's the idea.
Right.
So a lot of guys get confused with that.
Yeah, they always want the fastest speed, right? Like I want to put it at 160 megahertz wide, and so I get the fastest possible speed. But then the whole network doesn't work well because you only can have one access point at that. And those are consumer APs that not any business class will even allow you to do that, really.
Yeah, exactly. So you go from, hey, I have coverage in part of my house to, or I don't have coverage in my house and I need coverage throughout my house. But as soon as you add in more access points, you may have to turn down the channel width.
Yeah.
Which means your overall average speed might slow down because now you need coverage throughout the house. And the reason you're doing that is because you might have more interference. Now, you can always try to go to 80 megahertz, with multiple access points, and see how that works, and it might be okay. But just know that you might have to turn it down to 40.
Yeah, and I mean, if you are at 80, depending on how many channels you have, if DFS channels are enabled on your access points, you'd want to reuse those channels. So if you're on like 36, 52, let's say you had 4 access points, you could go 36, 52, 149, and then you could use 36 again. But you don't want to go somewhere in the middle. Like, you don't want to go to channel 36 and 40 and put them next to each other, because you got co-channel interference. You'll start dropping packets. As long as you reuse that 80 megahertz channel on the same exact channel, then they'll basically share that available throughput, right? So that's usually okay. But yeah, if you're still experiencing problems, then they could drop down to 40 megahertz wide channels, where you have many more channels. At least 6 without DFS. So yeah, that's something to think about. And also, like, the Wi-Fi built into these routers that your internet provider is giving you is usually the cheapest possible. Like, they're gonna advertise it as being like super fast and all this, but they put the cheapest chips in there, whereas like just about any standalone access point is gonna work better, right?
Yeah, exactly. Yeah. Well, I mean, the modem is built for like multiple jobs, right? Mm-hmm. Whereas like an access point is built for one job, a single job. It's really good at that one job, and that is allowing Wi-Fi access to the network. So there's a lot more attention paid to the design of an access point, the memory, the CPU, and so on. So that's another thing to consider.
Yeah, because that combined device, it has the memory and CPU that they afforded that device is being used for the modem, for the router function, for like DHCP and NATing, and then also for the Wi-Fi. And any one of those 3 things could slow down the entire network, right? If you get a big load on it. So
definitely.
So by distributing it to multiple access points, those access points are going to do their job only serving up Wi-Fi. The router and modem can do their jobs, just forwarding those packets to and from the internet.
Right.
So that's something else to think about. All right, guys, we're almost out of time here. Got to get to work. I have to. Everyone else is off today, but I never get to take the day off, so I got to keep selling. All right, Brian.
I had to take the day off today.
Yeah, you had to. I know. All right, guys. Remember to like and subscribe for more help with Wi-Fi. We'll be back next week with another exciting video cast. All right, bye.